Hi AP Calc, this is Mr. Rigger again. So let's talk about limits of functions involving radicals. So here we have the limit as x approaches c of x in a root with the nth index. Remember, this is the same thing as x to the 1 over n power. So basically we have a power again. So we can just pop that c in for x. So this is going to be c to the 1 over n, or this is also going to be the nth root of c. So again, direct substitution is how we find this limit. Now, is there a distinction between n being odd and even? There is. When n is odd, this is valid for all c, and when n is even, it's only valid for c is greater than 0. So why is that? Well, if n is odd, we're looking at cube root, fifth root, eighth root, and if you remember, negative 3 cubed is going to give me negative 27. Negative 3 times negative 3 is 9 times negative 3 is negative 27, so we end up with a negative number back, which means the cube root of negative 27 can give me a negative number. But the square root of negative 9 has to give me an imaginary answer. So anytime there's an even root here, 2, 4, 6, 8, 10, we're always going to get imaginaries if we have a negative number over here, which is why c has to be greater than 0 when n, the index, is even. So the limit of a composition of functions, or a composite function. This is it's kind of some weird notation, but if you're taking the limit of f of g of x, and we know that the limit of g of x as x approaches c is L, we can rewrite this as f of the limit as x approaches c of g of x. So here the f actually pops all the way out. Well, we know that the limit as x approaches c of g of x is L, so this is then just f of L. So that becomes nice and easy for us. Real quick, trigonometry. Again, direct substitution is the key. So what's the limit of sine x as x approaches c? Sine c. Cosine c. Tangent c. Cosecant c. Secant c. And cotangent c. Pretty easy, direct substitution. Now, of course, c has to be in the domain. So here, x is all real numbers, here x is all real numbers, but we have asymptotes in the rest. And we have to make sure that we're not letting c trying to be one of those undefined places where we have an asymptote. So, how do we evaluate the following limits? Well, we directly substitute if possible, as long as we don't break any rules like a negative under an even radical index or a 0 denominator, we're fine. So this is just going to be square root of 0 squared plus 4, which is square root of 4, which is 2. Easy peasy, right guys? Next up, we're going to go ahead and just jam a 3 in for x. And we can simplify that. Here, tangent of 0. Well, remember, tangent is sine over cosine. Sine of 0 is 0, cosine of 0 is 1, so we get 0. What about this one? Well, put a pi in. Pi times cosine pi. Well, pi is pi, and cosine pi is negative 1, so I get negative pi. What about over here? This is the same thing as sine squared 0, which is, if you remember, sine of 0 squared. Sine of 0, we already said, is 0, so this is 0 squared, which is 0. Let me go back and finish this one up, just in case you're one of those people who like things to be complete. 2 times 9 minus 10, cube root. This is 18 minus 10, which means we have the cube root of 8, which is 2. And that is the first part of section 1-3.